Example 4. Describe the similarity transformation that maps trapezoid PQRS to trapezoid WXYZ. Now, first of all, make sure you're paying attention to order here because we specifically have to get to the first one to the second one, which means we're going from the larger one over to the smaller one. So starting out here, if I'm thinking of a similarity transformation, I know that it got smaller. So my dilation or my scale factor better be less than 1 because I'm going to the smaller one. First thing I'm looking at is that it's kind of facing the wrong direction. So we have to get it flipped across. Well, I'm thinking that's a reflection. And then more importantly, is it a reflection over the x-axis or the y-axis? Well, it's kind of being folded from left to right, so that would be a reflection over the y-axis. If I were actually to do that, point R would stay put, point S would come over here and be out here at 6, point P would kind of just come out here, and point Q would flip over, and we'd be looking at this trapezoid. But now I have it facing the right direction as the green one, which is what I'm trying to get to, but it's not the right size. So that means I need a dilation with a scale factor of something. And I know it has to get smaller, so my scale factor has to be less than 1. If I look at one point, I'm going to do W and my P prime. And right now my P prime is at 6, 3. And I have to get that point to come down here to W, which is at 2, 1. Well, what do you do with 6 to get it to 2? You divide by 3. What do you do to 3 to get it to 1? You divide by 3. So that would tell me that I'm dealing with a scale factor of 1/3. If we test that out on another point, I could do point Z. This point is at 6, -3. This point is at 2, -1. If I divide this by 3, I get 2. If I divide this by 3, I get -1. It looks like it works. So over here, step 1 and step 2 would be your similarity transformation.